Hi everyone, in this video I want to talk about finding and verifying inverse functions. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. What is the most intense adventure sport you would be willing to partake in? So let's talk about inverses. So this is typically an Algebra 2 concept. It's possible that you would have questions related to finding an inverse or checking to make sure two functions are inverses of each other. And I doubt you would see a graph, but I think graphs would be considered fair game. So let's talk about two different types of directions. One would be find the inverse, and then the other is here are two functions, decide if they are inverses. So what does an inverse mean? Well, if you have, let's say, an XY chart, and you have 1, 2, 3, 4, 5, 6, the inverse of this function here would be just the x and y's would all be flipped. 2, 1, 4, 3, 6, 5. So like on a graph, if we have a graph here and we have 1, 2, 3, 4, 5, 6, the inverse is going to be reflected over the line y equals x. So I like to actually use this concept with the concept of a smiley face. What would the inverse of that smiley face be? Well, a lot of people think it would be like if this is the mirror image line, then the inverse would be right here. But you actually have to make sure that every point on this original function is the exact mirror. So the smiley face actually goes like this. So moral of the story is whatever x, y pair you have in the original function, whatever it may be, the inverse would just be all the x's and y's flipped. So if it says right here, find the inverse of a function, let's talk about what the steps would be. Well, first you establish that this hk, or h of x, that is the same thing as y. So then the y is going to be our, think of it like the y here and the x would be the x here. So the first step would be, let's just write them out here and then I'll actually do them. So first step would be flip x and y. That is literally just flip them. So instead of a y here and an x here, you would go x equals the negative 5/9 y minus 20 over 9. Then next you solve for y again, or the f of x. So what I'm going to do here is add 29th to both sides, cross those out. And then I'm trying to get y by itself. It's almost like going from standard form to slope intercept. It's those same decisions that you would make. So here you have x plus 20 over 9 equals negative 5/9 y. And I need to get y by itself. How do I do that? Well, I could divide by a fraction, but that sounds like a lot of work. So instead, I'm going to multiply both sides by negative 9 over 5. Okay, then I'm going to get negative 9/5 x. And then minus, here's where I need to multiply. So that's going to be, well, the nines can cancel. So instead of just multiplying that all out and then simplifying, I could cross cancel here. So 9's cancel. And then 20 over 5 is just 4, right? So isn't that just going to be minus 4 equals, and then this 5/9 and 9/5, those will cancel. They're negative, but they multiply to be positive. So equals y. And there we have it. Y is equal to, it's isolated. So there's our inverse. So the f of -1, or I should say f inverse. So f to the -1 power is the notation for inverse. And you would say f inverse of x equals, and then -9/5 x minus 4. Final answer. So looking at this, it's kind of funny. The 5/9 and the 9/5 are like flipped, versions of each other, but you really can't look at an original function and then figure out the inverse from there. So now, if you were given two functions and you were asked if they were inverses, what you can do is either go through all these steps here, or there's actually a different way. There is a theorem that says when you test these two functions, if f of g of x equals x, just x, not 1, not 0, but just a plain old x, and g of f of x equals x again, then the f and g are inverses. Okay, so that's something we'll remember. Okay, so let's try that. You will need to have seen or been taught the composition, so composite functions, before doing this. That is plugging g of x in for the variable of the f. So g of x is -x plus 3 over 2. That is going to be plugged in up top. So f of g of x would be f of, instead of g of x, -x plus 3 over 2. And that is going to be -2, and then -x plus 3 over 2 plus 3. So if I get x at the end of this, then it's going to look like they're functions. Let's see. So I have -2 and 2. Let's cancel those out and call that -1. So then that would be -1 times the quantity -x plus 3 plus 3. Okay, so that gives us x minus 3 plus 3. Hey, we do get an x. Okay, let's see if we get another one. We can't just get one, we need to get both. So now g of f of x is -2x plus 3 going in for the variable of the other, right? So I'm plugging f into g. That is negative the new variable, which is this here, plus 3 over 2. Now I'm checking to see if I'm going to get an x. So I'm going to get 2x minus 3 plus 3 over 2 equals, cancel, 2x over 2. Hey, it's going to equal x. So, moral of the story. Yes, f of x and g of x are inverses. Now, if you get a final answer where you get, say, equals 1 or equals 5 or something, equals 2x and equals 3x, those are not inverses. So you have to get x and x. Now, you might think maybe, what if you just take this and find the inverse of it? That might be faster. but I wanted to show you both ways. Okay, so let's try some practice. These problems are very, very similar. The directions would be the same. Here, you're just finding the inverse, and here you are verifying that these are inverses. So why don't you pause the video, try it, and I will reveal the answers. Okay, answers are the inverse function of the first one would be negative 2n minus 2. And the next one, the answer is no, because you don't actually get x and x as your answers. Or if you find the inverse of, say, I would choose the second one, find the inverse of that, you do not get that top one. All right, a quote for some inspiration. The measure of intelligence is the ability to change. Something that is very thought-provoking. So I hope this video helped you in some way, and feel free to leave the answer to the fun question in the comments, and you can subscribe if you'd like to keep up with new videos. Thank you.